Hello YouTube, today we're going to be doing another plane problem. I did one about a plane taking off, or no, landing, excuse me. I did a problem about a plane landing. Now we're going to do about a problem about a plane taking off. So, you have to, for this airplane to take off, you need to reach a speed of 75 meters a second. If the runway is a kilometer long and the airplane starts at rest and moves with an acceleration given by this function, what is the minimum value of k for the plane to take off? Okay, so first thing you always do, or at least what I always do, when approaching a physics problem is write what you know. So, we know initially it's not moving anywhere, so 0 meters per second. We know how fast it needs to be, so the final speed should be 75 meters a second. We know that starts from rest, so it starts at 0 meters. We're going to define our coordinate system to be where the plane starts from rest, and we know that it needs to travel 1,000 kilometers minimum. So we also have this equation here, and this is in the x direction. So this is I guess 1D motion or 2D motion, depending on how you look at it. So the equations for acceleration when dealing with the equation here is pretty much given. Now, if you want to find the velocity, well, how do you find velocity when given acceleration? Well, using calculus, you take the integral, and you get the velocity, and the integral of k of t would be 1/2 kt squared, but since this is an indefinite integral, you have to have that constant. That constant is going to be our initial velocity. Now, do the same thing. You want to find position, you take the integral of the velocity. And the integral of 1/2 kt squared is 1/6 kt cubed. But we also have to integrate v sub 0, or the initial velocity, which we would just add a t to that. But we also have to add our constant. What's our constant going to be? Well, the initial position. Okay, so using calculus, let's approach this problem. So this is what we're given. We're going to do the same thing again, showing the integration steps. I should show the integrals there, how we got that. Also shown there, how to get these functions, just showing it again. And the reason why the initial velocity there and the initial positions are not there when I'm doing the calculations above is because the initial velocity is 0 in this case. The initial position is also 0, so that's why they go away and they aren't present. Now, when you have these three variables and we're looking for k, one good thing to do is to solve for k and then substitute into the next equation. So solve for, well, I guess we can solve for time in this case. And then you could plug it in there and you can solve it that way and solve for k. But I'm going to show you a little easier way. You could do this just mathematically, but what I always like to do is I like to find as much information I can about the problem. So I solved for k, right, because that's what we're looking for. And I noticed that we have the final velocity, but we don't have the time portion. So I'm going to solve for the time portion, and we'll get back to this problem later and figure out what k is. So let's figure out how long it takes to get there. This is probably a good piece of information you'd want to know. And ironically, or conveniently, that is the next part of the question. How long did it take the plane to travel down the runway? Now, we did not finish this problem. We will go back and finish this in a moment, but let's take a look at this. So, using that formula we just got here, we know, and we have the position. How long does it take to go that distance is what we're looking for. So we simply plug in k to that equation, and then simplify, and you get 1/3 times the final velocity times the final time. Now that time is what we're looking for, right? That's what we want to know. How long does it take? That's time. So we solve for t, and we get 3 times the final distance over the final velocity. Well, hey, we plug in 3 times. Well, what was the final the final position is 1,000. 1,000 times 3 divided by 75 is 40 seconds. Okay, now that we have 40 seconds, let's go back here and make life easy. We got 40 seconds. Okay, so we just plug in 2 times 75 meters per second over 40 seconds squared, and boom, you get 0.09. Now, key, units. How did I know what the units are? Well, if you just paid attention when you're doing your calculations, you could figure that out yourself. Or if you just look at the equation, A of t, right there, equals kt. If I plug in k 0.09 meters per second cubed, acceleration is measured in what? Meters per second squared, right? And if we're multiplying by time, that's seconds. So seconds cubed, or 1/seconds cubed times seconds, will produce 1/seconds squared. And so that's what you're looking for, so you can check your units that way. So I just thought we'd throw out another plane problem. Thought it'd be cool to do some position velocity acceleration. It's always fun stuff. Hope this helped, and keep practicing.